energy. So this is page 12. And Richard Feynman reckons that energy, he doesn't understand what energy is, and so given he's got a brain the size of a planet, it's going to be pretty hard for the rest of us to understand what energy is. But we can approximate energy. We talk about energy all the time, and it can be a problem when a scientific word or a word that has meaning from a scientific perspective is used in everyday language, because that sometimes can cause misconceptions where we use it like we use it in everyday conversation, but then that might be incorrect from a scientific perspective. Probably the easiest way to think about energy is that energy is the ability to do work. Right, so I think we talked about this before. And we've already seen the work-energy relationship in that formula that we were using last term. And we know that work and energy both have the same units. What's the energy? What's the units for work and energy?
Joules.
Joules. Yep. So energy is in joules. Work is in joules. And on your formula sheets, I'm pretty sure it's written like that, isn't it? So where work is equal to the change in energy, or maybe it's a change in energy. Is that how it's written on your formula sheet? Yeah. And so we've got this relationship there between work and energy. Now, energy can come in a number of different forms, if you like. We do have a law, and that is the law of conservation of energy. So we can make a statement that energy cannot be created or destroyed. So what that means is that we can't, we talk about power generating and etc. Like a power station generates electricity and that sort of thing. It's not making it from nothing. It cannot be made in that way. What we are doing is having an energy transformation. Okay, so we can transfer energy from one form to another. Now, most of our energy, if we went back far enough, we could think about it as coming from either a chemical reaction or it could be from nuclear decay. So we don't, this is a part of our course, but of course this is a famous equation that shows us the relationship between mass and energy. And we're not creating energy from nothing if we have a nuclear explosion. What we've done is we've converted the mass into energy. So it's come from somewhere. So we've transferred, if you like, the energy from being in the format of mass to being in the format of heat. All right, so again, this is quite abstract and it's hard to visualize. But if we sort of use this as our guiding principle that we can't create or destroy energy, we can only move it around. And we, in an enclosed system, we can account for all of it. We know where all of the energy has come from and gone to. Now there's a list there of different sources of energy. So these are places where we're going to be able to transfer it from that format into another format. So mechanical energy, electrical, chemical, heat, light, nuclear. Okay, and so we can use this to then do work. Remember, if we're thinking about energy as being the ability to do work, then we can do work with these forms of energy. Now, there's not a lot in the booklet on energy transformations, but there have been questions on tests and exams about energy transformations, so I thought we might do a little activity which we might need laptops for.